Assalamu alaikum. Today we talk about how to read from the keyboard in 8086 assembly language. Usually there's an application, okay? So it's the application side. You need to read from the keyboard or to write on the VGA or to communicate with any peripheral device like the network card, sound card, whatever. You have two ways, or let's say more than two ways. One of them is to communicate directly with the hardware, okay? Which could be very difficult. Sometimes it's not possible for the programmer or the users to do that directly with the hardware, especially if you run the software of the application on different machines. The simplest way or the most direct way is to ask the help of the operating system. So you ask the help from the operating system. The operating system will communicate with the hardware, and it will provide you with the service you need. How to communicate with the operating system or ask using assembly language, ask the operating system to help you simply using interrupt function. Interrupts, there are around 255, okay, up from 0 to 255 interrupts can service you, not all of them, of course, but the most common one is we are going to use in the 8086 is interrupt 21 hex, okay? Interrupt 21, it has many functions. One of the function is function 1, let's say, is to read from the keyboard. I have another function, for example, function 2 is to print single character. Another function is function 9, print text or string. Okay, how to tell interrupt 21 that I want function 1 or function 2 or function 9 or other functions. Simply, you have to pass this number through AH. So, for example, move AH, comma 1. That means you need function 1, okay? Or 2 or 9 or other functions. If you look here, you will see that interrupt 21, it has all these functions and more. Another function, which is function 33, for example, it tells us later on to use the mouse. Function 10, on the other side, it has its own functions and services, different somehow than 21. If we look at 21, function 1, that means AH is equal to 1. It reads character from the standard input, which is the keyboard. An example, move AH, comma 1 and interrupt 121. Okay, now when you read it from the keyboard, what will be in return? It will be the ASCII code of the pressed key. So when you press any key, you will get the ASCII code of that key. This way, you can know which character is pressed, either an alphabet or a number or a space, backspace, whatever. So you can get back to the ASCII code and know which character has been pressed. We will take an example shortly. So you ask for the help of the operating system. The operating system will communicate with the key with the hardware, and you will get the value back through AL. This is for function 1. Okay, so let's take an example and continue. Okay, let's take an example. For example, I need to read from the keyboard 10 characters and store them somewhere in the memory. For example, let's say call it my name. Okay, the character read from the keyboard's byte size, so define byte. How many bytes I need to read? For example, I need to read 10 bytes. Okay, so 10, okay, duplicate of 0. That means I reserved 10 locations. Each location is a byte. Okay, later on I will fill these values, these locations with the keyboard pressed. Now, to read from the keyboard, again, interrupt 21 hex, which function, move AH, 1. So this way I read 1 character. How many characters I need to read? I need to read 10 characters. So I'm gonna use loop, okay? Loop L1, and L1 is located here. Okay, now I have to initialize where I should say store these values. So let's say load effective address. I can use SI, DI, BX. So let's just use SI, comma, my name. I loaded the address of my name into SI. So now I can store the value read from the keyboard at that array, move SI, comma, AL. As you can see, AL will contain the ASCII code I press on the keyboard. Increment SI to point to the next address. This way I'm ready. Let's emulate, no errors. Let me check about the memory. Okay, this is the memory here. Let's just rearrange everything here, okay? And memory here. Okay, so if you go one step, AX710, just 10, so I can see the data segment. Now, this is data segment. As you can see, this is all zeros, nothing there. Okay, now, single step, I'm initializing data segment, I'm initializing extra segment. Okay. Now, initializing SI, as you notice, SI will be keeping 0 because the address of my name is 0. Now, starts my loop. Move AH, comma 1. Now, AH is 1. Okay. Interrupt 21. As you can see, you will have this screen waiting for me to press any key. I'm going to press, for example, A small. A small, the ASCII code of the A small is 61 hex. Please keep your eye here. 61 hex will be shown here. So A small, as you can see, 61 hex, the ASCII code of A small. Next, I'm going to store this at the memory. Keep your eye here. 61 will be placed here now. As you can see, 61 is placed here. This is the ASCII of 61, which is A small. Increment SI. Now SI will be pointing to the next location. Next step, loop. Sorry, I didn't initialize CX. So CX will be decremented, but what was the value of CX? I didn't initialize it. That was my mistake. Okay, so keep in mind, you could do mistakes while doing assembly language. Tracing the program will help you to allocate those mistakes and solve them early. Okay, so next, reading again. Let's say I'm gonna press space 20 hex. This is space. You see 20 hex. Okay, will be located there. Now space here will be 20 hex. I now can run. Now, every character I'm pressing here will be stored here. So please keep your eye. B, C, D, E, F, G, H, I, Y, S, T, whatever. Okay, so each character I'm pressing will be stored here. That's help me to read from the keyboard, text, store it in the memory. Later on, I can process this text. Of course, if you want to fix my program, you have to initialize CX. Good luck.